Ladies and gentlemen, I'm proud to have the opportunity to attend this conference on global path. First, I would like to introduce myself. My name is ZHAOLEI, a PhD student from Southeast University, China. My presentation topic is assessment on the fire properties of blue hunger. It contains 6 parts, that is, research background, field inspection, experimental study, result discussion, and repair strategy. Fire is an exceptional severe hazard to which those may be subjected during their lifetime. For example, on March 4, 2017, a severe vehicle collision happened on the Suspension Bridge and caused a big fire which lasted more than an hour. This is video from accident site. After the accident, field inspection was carried out immediately. The vehicle involved in the accident were completely destroyed, and fortunately there was no casualty resulted from the event. 400 were seriously damaged, and no broken wires were observed. Previous studies have revealed that high-strength steel lose strength and ductility after high temperature, and so inferior fire resistance due to its high thermal conductivity and low specific heat. As a result, fire can induce significant degradation of load-bearing capacity of hunger during fire accident. Besides, hunger are also prone to fatigue damage, as they subject a large number of cyclic fluctuations induced by vehicle and the wind. To study the mechanical properties of steel wire after fire, an experimental program was designed. It main contains of 2 steps. First, heat the specimen to the desired temperature by an electrical furnace and subsequently remove them from furnace and cool down to room temperature. Second, conduct tensile test and fatigue test on specimens. All specimens in this test were identical to that of one used in the Suspension Bridge. To study the effect of heating temperature on property of steel wire, the specimens were heated to different temperature ranges from 100 degrees centigrade to 800 degrees centigrade, and 2 cooling methods, air cooling and water cooling, were investigated and compared. The air cooling method is to simulate the natural extinguish of fire, and the water cooling method is to simulate the fire was put out by a fire node. The left picture shows the specimen after a tensile test. The middle 2 pictures illustrate the stress string curves obtained from tests and the right picture summarize the strength and ductility will vary with temperature. As can be seen, for temperature below 500 degrees centigrade, only slight reduction of strength was found. Above 500 degrees centigrade, the strength of specimen began to decrease rapidly with increasing temperature, together with a dramatic reduction in final stain in the same time range. Compared to two kinds of cooling method, nearly no apparent difference were observed below 700 degrees centigrade. When the heat temperature reached 800 degrees centigrade, there was nearly no stain in water cooling specimen at failure, and the specimen was filled in pure brittle manner. This table and figure show the influence of heating temperature on fatigue property of steel wine. According to the fatigue test, it is found that when being heated under 5 degrees centigrade, all specimens could endure 2 million load cycles without fracture, as required in the code. Fatigue level significantly decreased after the temperature rose to 600 degrees centigrade, and there is a slight difference between the cooling methods. Since the fire accident lasted more than an hour, in order to investigate the influence of heating, duration, and the mechanical properties of steel wine, tests were conducted on steel wine heated to 500 degrees centigrade with different exposure time. It is seen that strength and ductility decreased with increasing exposure temperature, and specimens exhibit more losing in ductility than strength in the heating process. This page shows the influence of heating duration on fatigue property of steel wine. As expected, the decreased trend of fatigue with various exposure temperature is similar to that of strength. A decrease in the number of cycles to failure with during exposure time was observed. The above tests were performed keeping specimens unstressed while heated. However, it is noteworthy that when the fire accident happened on board, high tensile stress exists in steel wines due to raised self-weight and traffic to simulate the actual fire scenario. Load was applied to some specimens in this study. A specialized test setup was designed to make steel wine heated while subjected to certain tensions, as shown in the left picture. The stress strain curves of specimens tested under different stress conditions and temperature are shown in the middle figure, where the overall stress strain response of specimens was similar and different per stress condition until 400 degrees centigrade, no matter how high the per stress was. The variation of stress under 10% per stress was nearly the same as one without per stress. It dropped slightly for specimens and 20% per stress when the temperature above 400 degrees centigrade. A remarkable strength reduction was found when the stress increased to 30%, the variation would directly follow the same trend. This picture shows the number of cycles to failure after being infected with various stress. It can include that stress can significantly reduce the fatigue resistance. Under 400 degrees centigrade, all wine were able to resist 2 million fatigue cycles. However, beyond 400 degrees centigrade, the number of cycles to failure with initial stress dropped significantly as temperature increased. To make a comprehensive understanding of fracture mechanism, the fractured section of specimens after fatigue tests were sorted by scanning electronic microscope as shown in figure. As seen from the image, the fracture surface can be divided into two parts. The first is the so-called crook path, so-called crook growth area, where the fatigue crook initiate and propagate. It is smooth honeycomb shaft as shown in the picture A. The second is the instant rupture area as shown in the picture B, where the specimen feels instinctively it is somewhat rough with some redishing fiber and shear lips. Moreover, metallographic analysis were conducted. It is seen that the microstructure gradually changes during the heat and cool process. This is the root cause of mechanical porosity. According to the assessment from the fire department, the maximum temperature of hunger was estimated to have been reached 600 degrees centigrade because it is very close to the fire source. Therefore, the strength of hunger is evaluated to be reduced by 40%. Hunger was judged to suffer irreparable damage by fire and not probable to continue. Hence, the bridge authority decided to replace these hungers. A novel device was designed for replacement work. The picture taken from the site is shown in the right picture. That's all. Thank you.